Hello dear friends, welcome to our program for Chemistry 3rd Secondary Stage. Today we have a new lesson or a new part about organic chemistry that we talk about esters, and we have some part of or some information about about carboxylic acid. Let's see our lesson today. Concentrate with me very well. Let's go. First of all, we have esters today, but we have some properties of carboxylic acid to understand the meaning of esters and the preparation of this type of compound. Let's go to see. We have chemical properties of carboxylic acids. Carboxylic acids react like any other type of acids, forming salt when they react with alkalis or carbonates and metals. So here, if I have metal or carbonate or alkali react with carboxylic acid as any type of acid, as any type of mineral acid. Let's go to see this. Here we have ethanoic acid CH3COOH and react with NaOH, sodium hydroxide. What will happen here? Sodium ethanoate that produced. We have the sodium that replace hydrogen as any reaction between the acid and base. So because what? Because the sodium is more active than hydrogen in the chemical activity series. It's very easy to know this. So we have CH3COONA plus what? Plus H2O. We have a base here. Any acid with any alkali give us salt and water. Like any acid of carboxylic acid with any type of base or type of alkali solution or alkaline solution, that makes what? That makes sodium ethanoate, that's like, and plus what? Plus water. So it's the salt and water. After that, ethanoic acid that react with sodium carbonate. So the sodium ethanoate also that produced as a type of salt. And we have the carbon dioxide because here we have the sodium carbonate. Carbonate produces what? Produces the CO2 plus H2O in many types of these reactions. So here we have carbon dioxide, water, and the salt of sodium ethanoate that produced from the reaction between acid or carboxylic acid and sodium carbonate. After that, we have ethanoic acid or the carboxylic acid that react with metallic sodium. So here the sodium ethanoate that produced also. But here we have hydrogen, okay? The hydrogen that produced. Why? Because sodium replaced hydrogen because it is more active than this one, more active than hydrogen in the electrochemical series or chemical activity series. It is easy to know this information. After that, we have aromatic carboxylic acids. We have this, the second type of carboxylic acid that form esters. What's meant by esters? We will talk about this after a period of time. So here the aromatic carboxylic acid. They are compounds that contains one or more carboxylic group attached to benzene ring. So one type of this group or carboxylic group, one or more, one or two or three or any one of them or this number. So here this is one group that attached to the benzene ring without one hydrogen atom. So we have the benzoic acid C6H5COOH. And after that we have two groups that attach it to one benzene ring. It's what? They are compounds contain one or more carboxylic group attached to the benzene ring. We have this example, it's called phthalic acid. It's C6H5COOH by 2. Two groups attached to the aryl group C6H5, and here we have this COOH in each one of them. After that, we have the salicylic acid. It's new thing. We have one carboxylic group. It's very easy to know this. And we have another group here that's called hydroxyl group. Hydroxyl with carboxylic that attach it together to the benzene ring. Why? Because here this form another type of acid that called salicylic acid. It is very important one in its uses. Why? Because it used to make what? To make aspirin. for making or for treatment of headache. This one salicylic acid that's used to make what? To treatment of headache or common cold. After that, we have the preparation of each one. Benzoic acid is prepared by oxidation of toluene. Here it's the big difference between the preparation of carboxylic acid in the aliphatic groups and in aryl groups. Benzoic acid is prepared by oxidation of toluene. Toluene, it means benzene ring, and we have methyl group CH3, or benzaldehyde by oxidizing agent in 400 degrees centigrade of the presence of V2O5. V2O5, it means what? It means vanadium pentaoxide. It is an oxidizing agent, very strong oxidizing agent that used to prepare some kind of chemical compounds in the industry or in lab. So here we have toluene C6H5 CH3, and in the presence of 3 oxygen molecules and in the presence of V2O5 and the temperature 400 degrees centigrade, change it into what? Change it into COOH, benzene ring, or benzoic acid. So here we have the uses of carboxylic acids. Formic acid, it's secreted by ants, and it is used to making dyes, insecticides, drugs, and plastics. So it has many or widely using in the industry. Formic acid, it's very important one. So this formic acid that's produce another one for information, we have formalin. It means the liquid that used to preserve dead bodies of some living organism to study it in the lab. And after that, we have acetic acid, CH3COOH, is used as a starting material in preparation of many organic compounds such as synthetic silk. Synthetic silk, it means حرير, الحرير الصناعي. We use this one or acetic acid as a starting compound or a starting material to prepare organic compounds such as synthetic silk. Number 3, we have benzoic acid. It's springly soluble in water. It's converted into sodium salt to be soluble in water and easily absorbed in human body. Again, it's very important to know this information. Benzoic acid, springly soluble in water by itself, but it converted into sodium salt by a reaction between what? Between sodium and benzoic acid in some cases. So let's be soluble in water. Why? Because it is to be easily to absorb it in human body. We use it in human body. We use the sodium benzoate. Yes. Why? Because sodium benzoate is used in preservation of food to prevent growth of fungi and bacteria in food. Again, sodium benzoate, it is used in many things of types of food, like what? Like jams, like some kind of foods in cans, like any type of food like fish, like for example some kind of juices and so on. So the benzoic acid, it is used or changed into sodium benzoate first to make what? To make this type of preservation of food to prevent the growth of fungi and bacteria in our food. Now we have a new part about what? About organic chemistry. We have another type of compound that produced from the carboxylic acids. It's called esters. What's meant by esters? What are the types of esters? Let's go to see. It's very interesting one because we use it, we know it in many fields of our life. Let's go to see the type of this compound. Concentrate with me very well. Now we have esters. Esters have characteristic smell, good smell, and are often used to flavoring and perfumes. Mister, we have perfume that contains a type of ester. Yes, the type of esters that found in many types of what? Of fruits, of vegetables, of anything, of some kinds of flowers that has good smell, so they are esters. Ester have characteristic smell and they are often used to flavoring and perfumes. Why? Because this compound that produced from these carboxylic acids that found in the fruits and flowers and many types of vegetables. Here we have another thing about esters. We have examples here. These examples we have here in this picture, we have apple. Apple, it has what? It has a characteristic odor, or it has good smell. But here we have propyl ethanoate, it smell of pears. Pears, it means comitra. So propyl ethanoate smell its pears. And we have the butyl butanoate, it's pineapple, ananas. Each one of these fruit that has specific type of ester that has good smell and good taste. So the esters is found in these fruits and vegetables to make its taste or characteristic taste of each one of them. And we have methyl butanoate smell, it's apple. Methyl butanoate, it's what? The smell of what? Smell of apple and the taste of apple. After that, we have it contains the esters. We have the definition here. They contain the group of atoms. This group of atoms, it's what? It's COO. Where is H? Replaced. Replaced by what? Replaced by another group of another type of compound. So which is written COO, and we have two bonds in the two sides here. Again, the esters, the specific group of the esters, it contains a group of atoms COO. Esters are made of from what? Made from the reaction of carboxylic acid with an alcohol. So the carboxylic acid plus alcohol give us ester and water. Again, it's a base. It is a rule. We have carboxylic acid plus alcohol give us ester and water. So the ester or water here, it means what? It means this is the production of reaction between carboxylic acid and alcohol. After that, we have esters that are named after the alcohol and the carboxylic acid from which they are made. So it takes a part of the carboxylic acid in its name, take the part of carboxylic acid and the part of alcohol. So they are made. The alcohol gives the first part of the name and the carboxylic gives the second one. Ester always end with anoate. Anoate, it means this part of what? Of the ester here. So we have alcohol or carboxylic acid, they are react to each other forming the ester. We have methyl ethanoate, we have propyl ethanoate, we have methylweight, methanoate, and so on. So here this is the name of the ester that comes out from the carboxylic acid and the alcohol in the same time. Alcohol is first and the carboxylic acid is second. Here we have match the carboxylic acid with an ester if can form. So we have bentanoic acid, we have propanoic acid, we have butanoic, and so on. So which one of the second column that contains the ester that formed from what? From this one, from these types of carboxylic acids. Here we have bentanoic acid. Bentanoic acid, which one? We have this decyl bentanoate or methyl propanoate, or which one of them? We have bentanoic acid, we have bentanoate. It's very easy. So propanoic acid, we have propanoate. Here this one. But here we have butanoic acid, we have ethyl butanoate, butanoate. Here they are with each other. And here we have methanoic acid, we have methanoate, and so on. We have here the hexanoic acid with hexanoate, and here we have ethanoic with ethanoate. It's very easy to make this. Why? Because this is what? This is each one of the carboxylic acid that contains the phrase oic acid or methanoic acid, ethanoic acid, we have methanoate, we have ethanoate. So this is the nomenclature of this type of compound that called esters. We have here fill the missing information of the table. We have carboxylic acid, and here we have the alcohol. So, and we have ester. So here we have ethanol. Ethanol, which one of them? Ethanol here, I move this one in each one of these parts or squares here. So ethanol, we have this one, ethyl propanoate. The first one we have propanoic acid, and which alcohol? That gives ethyl propanoate. So propanoate, it comes out from propanoic acid, and here we have ethyl, that's called ethanol. So here is the first one. And here we have methanol. Methanol here, it means what? It means the alcohol that used to make what? To make this one, like this. But here we have ethyl ethanoate. It is the name of what? Of the ester. Why? Because here we have weight or anoate. Anoate, it means what? It means this part of the ester. So which one here? We have ethanoic acid and ethanol. We have ethyl ethanoate. So this one is right here. And after that we have ethanoic acid. Which acid? Here, this is the methyl ethanoate. So we have ethanoic acid that found here. And after that we have methanoic acid. It's very easy to know this. Methanoic, it's like the, we have here, this is propyl methanoate. Methanoic, it's methanoate. Propyl, this is propanol, this is propyl, and so on. And we have the last one here, we have propyl butanoate that found here. So I need the correction here, and well done. After that, now we have the preparation of esters. How can you make esters? How can you prepare esters? Made of what? Made by reaction between carboxylic acid with an alcohol. So what the preparation practically that's happened here? We have here methanol, for example, as alcohol, and we have propanoic acid here that mix to each other in the presence of acidified medium, in the presence of H2SO4, for example, dilute, and makes what? It makes this reaction like this. Here we have making ester. Click play to find this. We have the alcohol here. Alcohol, this one. I have stage 1. The flask contains 1 centimeter cube of concentrated sulfuric acid. And we have some drops of carboxylic acid. So we have two types of acid. We have sulfuric acid to make the acidified medium, to absorb the most amount of water. And we have 10 centimeter cube of ethanoic acid and 10 centimeter cube of ethanol also. So transfer into the flask. After that, we have considered the filter and put it here in the flask and heat the flask and make the cooling system like this. We have the water that move inside here and the water comes out like this. So here we have the heat energy here. So the condenser is fitted and steady flow of the water keeps the glass cool. Keep the glass cool. The reaction mixture is heated, and as it boils and evaporates, the vapors travel up into the condenser. So after that, we have stage 3. The cold water running through the condenser cools the vapors, turning them back to the liquid. They then drip back down into the flask. So this is what? This is the cooling system here. The process is called reflux. And after that, we have after reaction. The mixture has been heated for an hour or so. So it's what? It's left to cool. After that, the mixture can be filtered by a filter paper to make what? To alkali, and the weak alkali is added to neutralize what? Neutralize this type of compound that produced from any amount of excess of acid. And after that, it makes what? It contains the ester, and in the bottom layer that contains byproducts. And after that, the ester that's collected here and it's found here and put in another flask, and put some amount of what? Some drying agent such as solid calcium chloride that absorb the most amount of water that found in this compound like H2SO4 first. Finally, we have what? We have dried this ester, purified by distillation system to make what? To make this ester, okay, it's what? It's solid ore. We have in some kind of liquids and so on to make what? To make this type of ester that prepared pure without what? Without any amount of acid or any amount of excessive water. This is what? This is making an ester in our lab or in the industry. So here, what are the characteristic smell of esters? It's very interesting to know this. We have here alcohol. In the other one we have carboxylic acid. So if I put the carboxylic acid with any one of them, let's go to see what happened. Let's go. First one, which one I choose? Ethanoic acid or butanoic acid? Ethanoic acid. I put some amount here. After that I use the octanol. It is another one. So I put it here. What is this? This is what? This is the orange. Orange smell and taste, yes. Octanol with ethanoic acid. And another one we have next. Ethanoic acid and we have butanol with each other and put it here in this system. It's what? It's banana. We have the banana juice, the smell and what? And taste of banana. It's very easy. And we have another one. We have next here, we have ethanoic acid and we have ethanol. Ethanoic acid and ethanol. We have what? We have some kind of fruits like strawberry. After that, it's very easy. So ethanoic acid in last time, we have methanol. It makes what? It makes this type of glue. The smell of glue, not taste. The taste of glue is very bad. It's poisonous one. But we have the smell of glue. It's what? It's the ethanoic acid and methanol. So it is what? It is methanol here. They react with ethanoic acid to form methyl ethanoate. Methyl ethanoate. It's very easy to know each one of them. And we have next one. I use here, we have butanoic acid. Butanoic acid, I add some amount of this with octanol, the first one. What will happen here? We have what? We have, this is the type of carrot. And after that, the smell and taste of each one of them, that's called ester. So second one, we have butanoic with butanol that form what? From pineapple. Pineapple taste